Rightio class, in for another lesson of science today. Hands up, who can tell me what we've been learning about previously in this unit? Emma?
Heat.
Heat.
Heat energy.
Heat energy, precisely. What specifically about heat energy have we been learning about, Michael?
We've been looking at different things that produce heat, like stuff that's hot.
Produce heat, yep. So the sources specifically. Heat sources and transferring of heat from one object to another. Okay. Now, today we're going to do a task, and I'm just going to model it up here for you. We are going to have various different materials. My object that I'm going to be testing today is a metal little tin that is empty. Can anyone tell me, if I sit this on a heat source, do you think that this will get hot, or will it get cold, or who can tell me? Hands up.
I think it would get hot.
Hot. Okay, why do we think that? Any ideas? Emma?
When you leave metal things in the sun, they get hot.
Yes, that's right. And so if I leave it touching a hot thing or a hot source, such as this brick that I've just brought in from outside, okay, so we're going to test on multiple different surfaces for 2 minutes. I'm going to leave this here and it'll sit on that brick. When I take it off, we're going to feel it. We're going to write a sentence. We've done our prediction that it's going to get hotter. We're going to write a sentence in our book, and I'll do one on the board. What should my sentence say when I've observed what happens? What should I start with?
The object gets hotter.
Yeah, okay, that's a good start. The metal, we'll say metal object. Gets hotter, and where did I leave it? On the brick.
Yeah.
When it is sitting on the brick, the hot brick we'll call it.
Should we say it feels hotter because we felt it, or does it not matter?
We can say that it feels hotter. Good idea, Emma. Maybe that's something that you can put in your sentence. I'll leave this one on the board for us as we go and do our test. Now, let's brainstorm some ideas. What other things? Now, I'll give us our boundaries first. Everything in the classroom is fair game. I've brought in some other objects, some hot, some are cold. We're going to make predictions, like I said, 2 minutes. Now, we've also got outside the classroom, not in our kitchen area, but outside the classroom outdoors where we eat. But when we're outdoors, I need everyone wearing their hats because the sun is out, and I need to be able to see you at all times. So it is just in front of the classroom here. So let's brainstorm some ideas of what we could test. Anyone hands up? Emma?
An ice pack.
An ice pack. Cool. Ice pack. What else? Curtis?
A pencil?
A pencil?
Yeah.
Yeah. See what comes off the pencil. Would you use the pencil as your object that you want to see if it gets hotter or colder, or do you want to sit something else on the pencil to see if it gets hotter or colder?
I might sit something else on the pencil and see if it does anything.
Cool. What about you, Thomas? What's something that you might be interested in seeing whether the heat source will heat up or cool down your object?
A hot rock from outside.
A hot rock? Cool. And Michael, what about you?
My rubber.
Your rubber?
Yeah.
Cool. I would be interested in things like, what about the garden? What if we buried something in the garden?
Ooh.
Could bury something in the dirt? Now, don't forget we have to make predictions as well about the stuff that we do. Alright guys, so we've got some good ideas, and I'm sure that you're going to come across plenty more outside, remembering that even though we're outside, there are other classes nearby that are still learning, so I want everyone to be on their best behaviour. That means no loud talking. I know that this is group work, small group work, so you have to do a little bit of talking, but No loud talking and no silly business, otherwise I'll bring you back inside and you'll only be allowed to do tests in here. Okay, so I've handed out your objects. You've all got a different kind of object made of metal, it might be made of plastic, it might be made of wood. I'm going to give everyone half an hour. That's how long?
30 minutes.
Half an hour?
30 minutes.
30 minutes. 30 minutes. Everyone's got 30 minutes. Each test, what do we need to do? Emma?
Predict what will happen.
Predict what will happen, then we observe, and then we explain. Okay, so that's our explanation sentence, and if you write down your predictions, that'll help you remember as well, obviously. Now, 2 minutes per test, off we go. Alright guys, welcome back into the classroom. I was really pleased with how everyone worked today, and everyone got all their testing done, which is excellent. Now it's time for us to share some of our results so that the other students who didn't have the type of material that you had can gauge an idea as well of what might happen or what did happen. Okay, so Emma, I see you had a wooden peg. How did that go for you? Can you share some of your results for us?
Yep, I put it on the black concrete and it got really hot.
It did?
Yeah.
On the black concrete?
Yeah.
Yep.
And then I buried one and it was really cold.
Cool. Where did you bury it?
In the garden.
In the garden?
Yeah.
In the garden in the sun or in the garden in
No,
the shade?
in the shadows.
In the shadows? Okay, and it became really cold?
It wasn't really cold, just cool.
Oh, it just cooled
Yeah.
down? Did you put it straight in there after it came off of the bitumen, the black bitumen? I hope you went out near the road, young lady.
No.
Okay, good. Good. Curtis, what did you have?
I had a bit of metal I found.
A bit of metal?
Yeah, it was like a tuna can.
Tuna can?
Yeah.
And it wasn't sharp, was it?
No, it wasn't sharp.
Good.
No.
Didn't have the sharp lid on it? That's
No, it didn't
excellent.
have a sharp lid on it.
Where did you try and
So
get the heat sources to?
I put
transfer
one
heat?
on the playground outside
Yep.
in the sun, and it got kind of hot because it was sitting on the playground. Then
Yep.
the other one, I put it in my lunchbox.
Okay. And your lunchbox and in your bag?
Yeah, in my lunchbox in my bag.
Yep. So it was in the dark, it
Yeah,
was
it
in
was
the
in the
shade.
dark and it was in the shade. Yeah.
And what happened then?
It got quite. I had a cooler ice pack in there, so it got
Okay.
cold in there.
Yep,
Yeah.
that's good.
Hmm.
That's good. And you've recorded all that in your science journal?
Yeah.
I can see that. That's excellent. Good work. Awesome job. Now, Michael, what did you have?
I had just a bit of plastic, like the bottle tops.
Okay. Yep. And how did that work? Where did we test the heat transfers?
Well, like Emma, I put one in the garden.
Yep.
And buried it to see what would happen, and the other one, I just had on the grass and it was in the sun.
Both in the sun, or one in the garden was in the shade, or in the sun?
They were both in the sun.
Yep. And what happened when you? What did you feel when you pulled the plastic bottle top out of the dirt that was in the sun?
It was warm, but it wasn't really hot.
Okay. Yep. So
And
it was warmer than when you put it in there, or was it about the same? Or?
it's probably the same. It didn't feel much different.
Cool.
in
Awesome.
temperature.
And then where was the other one? You left it on the grass in the
Yeah,
sun?
just in the sun, and that one felt hotter.
Okay.
It wasn't like super hot, but it was a bit warmer.
That's good. So it had direct sunlight coming on it. So can anyone tell me what the heat source would be? Emma?
The sun.
The sun. That's right. The sun is transferring its heat into the plastic bottle cap, and the plastic bottle cap is obviously absorbing that, and that's what we feel when we pick up. All right.